Hey everyone, welcome to my channel. So in this video, I'm going to explain the solution to this specific coding question called combination sum. At the same time, I'm also going to introduce a general procedure about coding interview. So let's get started. So usually in the coding interview, you start to understand the question, what the question is asking you to do. If there is anything unclear, please bring out the question to the interviewer, so don't be shy. And also at the same time, think about some edge cases that can potentially break the general solution. So let's read through this problem. So given an array of distinct integers candidates and the target integer target, so return a list of all the unique combinations of candidates where the chosen number is summed to target. So you may return the combination in any order. So the same number may be chosen from candidates an unlimited number of times. So two combinations are unique if the frequency of at least one of the chosen numbers is different. So it's guaranteed that the number of unique combinations that sum up to target is less than 150 combinations for the given input. So my first question would be, is it possible for us to have some negative numbers within the candidates? If yes, then it can potentially cause some other issues. So let's read through these constraints. So it says that the candidate list is never going to be empty, so we don't need to deal with edge case when candidate is empty. And the next thing is, it's guaranteed that candidate I is within 1 to 200. And the third one is all the elements within a candidate are distinct. So this potentially solve most of my concern about the edge cases. And the last one is target is never going to be negative. It is within the range of between 1 to 500. So I think there's no edge case at this moment I can think of. So the next part is about finding a solution. So in this part, you will need to think about ideas how to solve this problem, discuss the solution with the interviewer, try to have a good discussion with your interviewer about the approach, so make it clear, and also at the same time do some runtime space analysis, and also you need to get an agreement with your interviewer before you proceed to the next step, do some coding work. So I'm going to explain the solution, and at the same time I'm going to explain the general approach. So the general approach is recursion plus backtracking. So you can see that we initialize this result, which is a list of the list we are going to finally return. So like for this example, we are going to return a list of a list, which is like this. And the next one, we are going to have a list which is a temp list. So the temp list is to store the temporary result, which can potentially be stored as one of the list within the result. And this one is used in the recursive function. And I also overloaded the combination sum function. So this one, it is a recursive function and it's a hopper function. So I passed several parameters. The first one is the candidate list, the candidate array. The next one is the index within the candidate array we are currently looking at. And this one is the current sum within the current sum of all the numbers within this temp array. And this is a target number. And the last one is the result we are going to update potentially. So if the sum is equal to target, which means all the numbers within temp sum up to target, then it is one result. We are going to new a result and then put it into the result list, and then we will return. If the sum is larger than the target, then we just return, because if we just keep putting more numbers, the sum is going to be larger and larger, so we are never going to arrive at the target. And then if the sum is smaller than the target, then we need to add. So there are two ways. The first way is we keep adding the number candidates index, or we just don't add candidate index while we look at the next number. So in this one, in this part, we will first add the candidate number at an index, and also we call this recursive function to pass in the candidates, the index. So we are still looking at the same number, the same index number. And because I put a candidate index into temp, so the sum is updated to this one, and I parse in the target, temp, and result. And at the end, because we are doing backtracking, we need to remove the last number we have added. So essentially it is this number from the temp result. And then we continue to the next part. So the next part, so if the index plus 1 is smaller than the candidate length, which means there's still some more room for us to do recursive function to visit the next number. So we are going to, so another branch is we visit the next number, which is IDX. I update IDX as IDX plus 1, and the sum is stayed as the same because I didn't add any number into the temp array. So this is about the general solution and about the code, how to solve this specific problem. So regarding the runtime, I would say the runtime overall, so let's say the target is equal to n. This is target. And let's say we have m. Let's say the length of the candidates array is m. So we are, and let's say the minimum thing within all the candidates, it is x. So the runtime is going to be n. So it is going to be m to the power of n divided by x to the power, this is all something like this. So the reason is, so let me explain why the runtime is like this. So essentially, the worst case is, so first of all, we need to think the worst case, like the longest candidate list. Let's say for the longest candidate list, it really depends on n divided by x. So n divided by x means we need at most n over x numbers to form a list, to form a result list. So if that is the worst case, then potentially we need to try all the m numbers so like for example, let's say we have those 3 slots. So and each slot we have m candidates. So there are m to the power of 3 possibilities. We can give different combinations for these 3 slots. So similarly, if we have m candidates and we need to fill in n over x slots, so the runtime, then all the possibilities bring up to m to the power of n divided by x. So that's mostly about the runtime. And space-wise, I think a result, the worst case for the space is going to be something like this as well. And now, so space-wise, this is mostly about the possibility. And also, I think space-wise, it should also have a n divided by x, because so there are this many possibilities to fill in, this many possibilities for the list, and each list has this many has a length that can potentially go this large. So I would say the space-wise, it is going to be something like this, and the runtime-wise, it is going to be something like this. So that's it for this question. If you have any question about this specific problem, feel free to leave some comments below. If you like this video, please help subscribe this channel. I'll see you next time. Thanks for watching.